Hello, friend. If you enjoy calm bedtime lectures like this one, feel free to like this video, subscribe to the channel, and tap the bell icon so you'll never miss a peaceful moment of learning before sleep. Now, take a deep breath. Let your shoulders relax. Allow your body to settle down and your thoughts to gently slow. This is your quiet time, your space to rest, to wonder, and to drift gently into the deep history of our world. You don't need to focus or remember everything. Just let the story carry you, slowly and softly, through time and space. Tonight, we begin a gentle journey. A journey not just through history, but far beyond it. To the beginning of everything we know. Not just your city, your country, or even your planet, but to the very origin of Earth itself. For as long as humans have lived, we've looked up at the night sky and quietly asked ourselves, where did it all begin? The stars above us seem so ancient, so silent, and yet they hold the secrets of everything, including us. The earth is not separate from the stars. It is made of their dust. It is not the center of the universe, but rather one small island in a vast ocean of galaxies. And yet, it is our island. It is home. And like every home, it has a story. A long, beautiful, and sometimes violent story. One that began billions of years before the first human ever opened their eyes. To understand where we come from, we must travel far back in time. Far beyond the pyramids, beyond the mammoths, beyond even the first spark of life. We return to a time when there was no earth, no sun, no moon, no blue sky, no time as we know it, only a silent darkness. And then, something began. But to tell the story of Earth, we must first tell the story of everything, because Earth was not the beginning. Before our planet, before our sun, before even the idea of before, there was something else. And so, we go further back, as far back as science can take us, to the very beginning of the universe itself. According to everything we know today, the universe began around 13.8 billion years ago. Not with an explosion in space, but with the beginning of space itself. This moment is what we call the Big Bang. Before that moment, there was no space, no time, no matter, not even emptiness, just nothing. Then, something changed. A point smaller than an atom began to expand, not into space, but creating space as it grew. Time itself began to tick forward. In the first moments, everything moved incredibly fast. The entire universe was hotter than anything we can imagine. A dense, glowing sea of particles and pure energy. Within seconds, the smallest building blocks of matter began to form. Protons, neutrons, electrons. Then, after about 3 minutes, the very first atomic nuclei appeared. Mostly hydrogen and helium, the lightest elements in the universe. But there was still no light. Not yet. The universe remained a glowing fog for hundreds of thousands of years. Light kept bouncing, unable to travel freely, trapped in the heat and chaos. And then, slowly, the fog began to clear. The universe cooled just enough for atoms to form. Electrons joined with nuclei, and at last, light could move. That ancient light, the first light, still travels through space today. It's called the cosmic microwave background, and scientists can still detect it, like a faint whisper from the past. This was the beginning of what we now call the visible universe, a place of stars, galaxies, and possibility. Everything we know, every planet, every star, every living thing, all came from that moment, from that first expansion, from nothing to everything. The universe had begun. It was expanding, cooling, changing. But there were still no stars, no galaxies, no suns to warm a planet, and no planets to be warmed. What existed was simple: light, energy, and the smallest particles. But over time, simplicity gave way to complexity. Tiny pieces began to come together, and from that quiet gathering, stars were born. It all started with clouds, enormous clouds of hydrogen and helium, stretching across vast distances in space. They floated silently, almost weightless. But gravity was at work. Slowly, patiently, gravity began to pull particles toward each other. The more they gathered, the stronger their pull became. Eventually, these clouds collapsed into dense, spinning balls of gas. And as they collapsed, their cores grew hotter and hotter. Then, something remarkable happened. At a certain point, when the temperature reached millions of degrees, the atoms at the center began to fuse. Hydrogen turned into helium, and in the process, it released incredible amounts of energy. A star was born. These newborn stars lit up the darkness of space for the very first time. They burned bright, and they began to shape everything around them. Some of these stars were small and gentle. Others were massive, short-lived giants that burned their fuel quickly. The biggest stars lived fast and died in spectacular ways. When they could no longer hold themselves together, they collapsed inward and then exploded outward in a powerful blast called a supernova. These explosions were more than dramatic. They were essential. In the heart of a supernova, heavier elements were created: carbon, oxygen, iron, gold. Elements that would one day become planets, oceans, trees, bones, and breath. In time, these elements, scattered through space, became the dust of the next generation of stars. And around those stars, new clouds began to form. Some of these clouds became stars again. Others became something else. Galaxies, swirling collections of stars, dust, gas, and dark matter, held together by gravity. Some had spiral arms. Some were round like glowing clouds. And some were just beginning. In one quiet corner of the universe, inside one ordinary galaxy, a new star would soon be born. Our sun was born about 4.5 billion years ago. It began like many other stars, as a cloud of hydrogen and helium collapsing under its own gravity. But it didn't form alone. Around the young sun spun a swirling disk of gas and dust, a glowing, chaotic ring of raw material. It stretched across billions of kilometers, filled with particles, heat, and motion. This disk was a place of constant collisions. Tiny grains bumped into each other, stuck together, and slowly began to grow. Dust became pebbles. Pebbles became rocks. Rocks became mountain-sized blocks of stone and ice. These growing bodies clashed and collided again and again, sometimes breaking apart, sometimes merging. Over millions of years, a few of them grew large enough to pull in more material with their gravity. They began to clear paths through the disk, becoming the first protoplanets. The sun, at the center, blazed with new energy. Its radiation pushed lighter gases outward, shaping where different types of planets could form. Closer to the sun, it was too hot for ice or gas to survive. Here, rocky planets began to take shape, small, dense, and solid. Further out, where it was colder, gas and ice collected freely. These would become the gas giants, huge planets with thick atmospheres and many moons. Our solar system, as we know it today, was starting to form, slowly, roughly, with endless change. But it was still far from peaceful. Among these swirling rocks and growing worlds, one would soon become very special. A small rocky planet, battered, heated, unfinished, but destined to become Earth. And before it could be a home, it had to survive fire, impact, and transformation. Among the many new worlds spinning around the sun, some were pulled into giants, others into icy wanderers. But one, small, rocky, and young, was in the perfect place. Not too close to the sun, not too far. This world would not have an easy beginning. It would be shaped by fire, by force, and by time. And yet, it would survive. Earth was born about 4.5 billion years ago, not as a calm blue planet, but as a sphere of chaos. In these early days, space was crowded. Pieces of rock and metal, left over from the formation of the solar system, crashed into each other constantly. Some were small, others were the size of mountains or even planets. One of these growing bodies became what we now call Earth. It did not form gently. Gravity pulled together fragments of dust, stone, and metal, compressing them into a hot, spinning ball. Each collision added more energy. Each impact melted more of the surface. The young Earth was covered in molten rock, a glowing liquid crust where nothing could survive. The sky was filled with ash and vapor. There were no oceans, no rivers, no blue, only heat, fire, and movement. Inside the planet, heavy materials like iron and nickel sank toward the center, forming Earth's core. Lighter materials floated upward, creating the mantle and crust. This process, called differentiation, gave Earth its layered structure. A solid inner core, a swirling liquid outer core, a thick mantle, and a thin crust floating on top. But even after Earth took shape, its violent youth was not. About 4.5 billion years ago, a planet-sized body, possibly as large as Mars, entered Earth's path. It had formed in the same region of the solar system. It followed a similar orbit. And one day, it struck. The collision was unlike anything we can imagine. Not just a simple impact, but a planet hitting a planet. The force of the crash was so powerful that it shattered both worlds at the surface. Molten rock and metal were launched into space. Vast pieces of Earth and the impacting body, now called Theia, were thrown into orbit. But not all of that material escaped. Some of it began to gather. Particles of rock and dust pulled toward each other, orbiting the Earth like a glowing ring. And slowly, quietly, those fragments began to form something new. A single, large sphere, shaped by gravity, cooled over time. This was the beginning of the Moon. Unlike Earth, the Moon cooled quickly. It had no atmosphere, no liquid oceans, no protective magnetic field. Its surface became marked with craters, each one a memory of impact. And it has remained mostly unchanged since then. But though it is smaller and quieter than Earth, The moon played a powerful role in Earth's future. Its gravity began to pull on Earth's oceans, creating the first tides. It stabilized Earth's axis, giving our planet a more consistent climate over millions of years. And it slowed Earth's rotation, helping turn chaotic days into steady rhythms. Thanks to the moon, Earth became more stable, more balanced, more ready for what was to come. The sky, once dark and empty, now had a companion, a mirror of stone, quietly circling above. And beneath it, Earth continued to change. With the moon now in place, the Earth began to slow, just a little. The days became longer. The surface, though still restless, started to cool. What had once been a sea of fire was now preparing to become something different, something solid, something we could one day walk on. Over time, slowly, over tens of millions of years, the outer layer of Earth began to change. As the molten rock at the surface lost heat into space, it started to harden. Bit by bit, a crust began to form. Thin at first, cracked and unstable, but enough to cover the planet like a fragile skin. This was not yet land as we know it. The crust was constantly reshaped by volcanoes, impacts, and rising heat from below. But it was a beginning. Deep inside, Earth's core was still hot and active. The motion of liquid metal within the outer core created something vital, a magnetic field. This invisible shield began to surround the planet, protecting it from solar winds and harmful radiation. It helped Earth keep its atmosphere and made life one day possible. At the same time, volcanic eruptions released massive clouds of gas, carbon dioxide, water vapor, methane, ammonia. These gases built Earth's first atmosphere. It was thick, dark, and unbreathable. There was no oxygen, no blue sky, no gentle breeze. But the atmosphere was forming, and with it, the planet was beginning to breathe. Meanwhile, something else was happening. As Earth cooled, water vapor in the air began to condense. Clouds formed. And then, after millions of years of steam, rain began to fall. And it didn't stop. It rained for thousands, perhaps even millions, of years. Rain fell on hot rock, turning to steam, then falling again. Over time, it collected in low places, filling the first basins, carving channels through the newborn crust. The first oceans began to take shape, vast, dark, and salty, covering most of the planet. Land was still scarce, but islands of crust poked through, floating on the slowly shifting mantle beneath. Earth now had sky and sea and solid ground. The fire had cooled, the chaos had quieted, and the stage was set for something entirely new to begin. The oceans had arrived. The earth was cooler now, calmer on the outside, but still alive with motion beneath. Waves moved across the surface. Rain continued to fall. Steam rose from cracks in the crust. And above it all, the sky was changing too. In Earth's early days, the atmosphere did not come from the outside. It came from deep within. Every volcano, every fissure in the ground, released enormous clouds of gas. These gases escaped from the hot interior, rising into the sky over millions of years. They formed Earth's first true atmosphere. But it was not like the one we know today. There was no oxygen, no blue sky, no breeze filled with scents of life. Instead, the air was thick with carbon dioxide, methane, ammonia, and water vapor. To a human, this air would be toxic. But for the planet, it was a beginning, a kind of protection. This atmosphere helped trap heat from the young sun. Even though the sun at that time was only about 70% as bright as it is today, Earth stayed warm enough to keep its oceans liquid. This warming process, called the greenhouse effect, was critical to Earth's survival. Without these gases, the oceans would have frozen. The planet would have turned into ice, and life, as we know it, might never have begun. Instead, the thick clouds kept Earth warm. They filled the sky with a heavy haze, filtering sunlight into a reddish glow. Storms rolled across the surface. Lightning danced across the horizon. Volcanoes continued to erupt, adding more gas to the sky, more minerals to the sea. The planet was still loud, still hot in places, but also more stable than before. The crust had formed. The oceans had settled. The atmosphere was holding. And under those ancient seas, in the darkness, something incredible was quietly forming. Above the surface, clouds swirled and darkened. The atmosphere was thick and heavy, filled with volcanic steam. And then, slowly, it began. Rain. A soft, endless rain that would last not for days or years, but for thousands, perhaps even millions of years. And with each drop, the face of Earth began to change. As Earth cooled, the water vapor in its atmosphere began to condense. Raindrops formed high in the sky, falling toward the hot crust below. At first, they hissed into steam on contact. The surface was still too hot, but over time, the land cooled further, and the rain began to settle. Drop by drop, hour by hour, the water collected. This was no ordinary rainstorm. It was a planetary flood, an ancient, continuous downpour that lasted for ages. The water ran across stone and ash. It filled the cracks, the valleys, the lowlands. It carved new paths through rock that had only recently formed. Eventually, it began to gather in great basins, creating the first oceans, vast, dark, and deep. By around 4 billion years ago, much of Earth's surface was covered in water. The oceans spread across the globe, leaving only scattered pieces of dry land behind. There were no continents yet, only rocky islands floating on a restless crust. No green, no life, no sound but wind and wave. But something extraordinary was happening beneath the surface. In the darkness of these newborn oceans, minerals from volcanic vents mixed with water and heat. The oceans were rich with chemicals: hydrogen, methane, iron, ammonia. The perfect ingredients for something entirely new. These waters, filled with energy and potential, became the cradle of life. Not life as we know it, not yet. But the conditions were now possible for life to emerge from chemistry. It would not happen overnight. It would take millions of years, countless reactions, countless failures, until something simple stayed. But the ocean was ready. It moved with rhythm. It carried heat, salt, and possibility. Earth, once a ball of fire, was now a world of water. And in that water, the story of life was about to begin. The oceans moved endlessly, waves rising, falling, carving patterns into the land. Beneath their surface, heat flowed from deep within the earth. Volcanic vents lit the sea floor with invisible fire, and all around them, the elements waited, not for a miracle, but for just the right moment. Somewhere, more than 3.5 billion years ago, in the darkness of the ocean, something new began. Tiny molecules formed naturally in the water, chains of carbon, hydrogen, nitrogen. At first, they drifted freely, bumping, breaking, recombining. But then, one of these chains did something unusual. It began to copy itself. This was not life as we know it, not yet. But it was the first step towards something alive. Over time, these molecules became more complex. They wrapped themselves in protective layers. They began to store information, to respond to their surroundings. Eventually, they became the first living cells, tiny, microscopic bubbles of life floating in the ancient sea. These were microbes, simple single-celled organisms with no brain, no heart, no eyes, no lungs. They lived in water without oxygen. They survived on chemical energy, often near volcanic vents, where heat and minerals poured from the crust. They were fragile, but they could reproduce. And with each generation, new variations appeared. Some failed, some vanished, but some endured. This was the beginning of biology, not loud, not fast, but steady. For more than 1 billion years, these tiny organisms ruled the planet, quietly, invisibly, completely. No animals, no plants, no predators or prey. Just single cells, multiplying slowly, filling the oceans with their tiny, invisible lives. They changed the chemistry of water. They began to shape the surface of the earth, and eventually, without knowing it, they would change the sky itself. But for now, the planet remained silent, a world of water and microbes waiting for its next transformation. For more than 1 billion years, life on Earth remained invisible, silent, simple, single-celled. But inside those tiny cells, something powerful was happening. A new way of gathering energy, a new way of shaping the world, a new kind of breath was being born. At some point, around 3 billion years ago, a new type of microbe began to appear. It looked much like the others, tiny, soft, alone. But inside, it was different. It had learned to capture sunlight. Using light from the sun, water from the ocean, and carbon dioxide from the air, these microbes created energy through a process we now call photosynthesis. But they also created something else, something no living thing had produced before: oxygen. To the microbes that made it, oxygen was just a waste. They released it into the water, bubble by bubble, molecule by molecule. And for a while, it had nowhere to go. The oxygen combined with metals in the ocean, turning them to rust. It seeped into rocks, changing their color and structure. It filled the seabed with iron-rich layers, many of which we still find today. But eventually, after millions of years, the rocks could absorb no more. The oceans could hold no more, and the oxygen began to build up in the atmosphere. This moment, called the Great Oxygenation Event, began around 2.5 billion years ago. To us, oxygen means life, but to most early life forms, it was poison. Many microbes, adapted to an oxygen-free world, simply could not survive. The rise of oxygen caused one of Earth's first mass extinctions, but at the same time, it created entirely new possibilities. Oxygen changed the chemistry of the planet. It made the sky clearer, bluer. It allowed for ozone to form high above, a shield against harmful rays from the sun. And it opened the door for complex life to evolve. Over the next hundreds of millions of years, new forms of life slowly began to appear. Cells with more internal structure, capable of working together. The building blocks of plants, animals, and humans were now quietly falling into place. It would still take a very long time, but Earth was ready. The air had changed, the oceans had changed, and life would never be the same again. As life was quietly transforming in the oceans and air, the planet beneath it was not still. Deep below the surface, Earth remained active, restless, alive. And slowly, the surface itself began to move. Earth may feel solid, but its surface is not fixed. It floats, gently, slowly, on layers of molten rock beneath. This surface, called the crust, is broken into huge pieces known as tectonic plates. And these plates are always in motion. They drift, they collide, they pull apart, they slide past one another. This process, called plate tectonics, began more than 3 billion years ago. It continues today. At the boundaries where plates meet, energy builds up and is released in powerful ways. Some plates push against each other, forcing land upward to form mountain ranges. Others pull apart, creating rifts and valleys. Some slide side by side, causing earthquakes. Below the plates, hot material from the mantle can rise up, breaking through the crust in fiery eruptions, forming volcanoes that shape new land. Over millions of years, these movements changed the face of the planet. Land masses joined together, then broke apart. They drifted across the surface of the globe, carried by the slow but steady force of mantle currents. At several points in Earth's history, most of the land gathered into single massive supercontinents. One of the earliest was called Valbara, followed by others like Rodinia and Pangaea. Each time the continents merged, they created new mountain chains, changed ocean currents, and shifted climates. And when they broke apart again, they scattered plants, animals, and ecosystems across the globe. The movement of the continents shaped Earth's climate, its biology, its history. Even now, the continents are still moving by just a few centimeters each year. But over millions of years, those small movements add up. Oceans open and close. Mountains rise and fall. Islands appear and vanish. Earth is not a static place. It breathes. It moves. And the land beneath our feet, is never truly still. The continents were drifting, mountains were rising, oceans were shifting and shaping new coastlines. But Earth was not only a world of stone and fire, it was also a world of climate, a delicate balance between heat and cold, sunlight and shadow, and that balance was never still. Throughout Earth's long history, its climate has never stayed the same. It has swung over and over again between extremes, deep freezes and intense warmth. These changes happened slowly over millions of years, but their impact was enormous. There were times when glaciers covered much of the land, stretching from the poles toward the equator. Oceans froze along the edges. Ice sheets grew several kilometers thick. One of the most dramatic of these periods occurred around 700 million years ago, a time scientists call Snowball Earth. Some believe that ice reached almost every part of the planet, turning Earth into a frozen world of white silence. And yet, even then, life continued. In the oceans beneath the ice, microbes and early organisms still found ways to survive. Then, slowly, volcanic activity released more carbon dioxide into the atmosphere. The planet warmed again. The ice melted. Rivers returned. Forests began to grow. This pattern repeated many times. Periods of warmth brought new possibilities. Plants flourished. Oxygen levels rose. Animals diversified. Some of the earliest complex life appeared around 600 million years ago in the warm, shallow seas of what we now call the Ediacaran period. Then came new ice ages, some milder, some devastating. Each shift in climate reshaped the land, the oceans, and the living things that called Earth home. Some species adapted. They evolved new shapes, new behaviors, new survival strategies. Others disappeared forever. But life always returned. Different, but present. Weaker in some ways, stronger in others. Earth's climate has always been a kind of rhythm, not predictable, but patterned. Controlled by the position of the continents, the tilt of Earth's axis, the brightness of the sun, and the invisible dance of gases in the air. Even now, the planet continues to shift between warmth and cold, though today, some of that change is driven not just by nature, but by us. Still, long before humans ever walked the earth, life had already endured fire and ice, extinction and renewal, silence and song. It adapted. It found balance. And it waited for what would come next. After fire and ice, after movement and silence, after destruction and rebirth, something new began to take shape. Not just life, but connection, not just survival, but coexistence. Earth was no longer just a planet with life. It was becoming a place where life could truly belong. By around 500 million years ago, life on Earth had begun to spread, not just in the oceans, but onto the land. Green algae, the ancestors of plants, began to grow in shallow water. They crept onto damp shores, anchoring themselves to rock and soil. In time, they evolved into mosses, ferns, and trees. Forests rose across the continents, bringing color and shelter to once barren landscapes. Insects followed, then amphibians, creatures that lived both in water and on land. Eventually, reptiles and mammals would join them. But this was more than a collection of species. It was the rise of ecosystems. Plants captured sunlight and produced oxygen. Herbivores ate the plants. Carnivores ate the herbivores. Bacteria and fungi broke down the remains, returning nutrients to the soil. Everything became interconnected. Every creature, from the smallest microbe to the largest predator, played a role. The air became more breathable. The soil became richer. The climate stabilized, at least for a while. Earth had become more than a rock with water. It had become a living system, a place where life shaped the environment, and the environment, in turn, shaped life. This system was not perfect. It could be disturbed by volcanoes, by impacts, by ice ages, but it had balance, not fixed or permanent, but dynamic, resilient, and always changing. From the rainforests to the coral reefs, from the deserts to the deep oceans, life adapted to fill every possible niche. And in doing so, it created something extraordinary. A planet that not only hosts life, but is shaped by it. A world where water, air, and land speak the language of biology. Today, scientists call this vast, interconnected system the biosphere. It includes every living thing and every environment that supports life. It is delicate, but powerful, and it has existed in one form or another for billions of years. Earth is not only alive, it is alive together. Every part depends on every other part, and through that connection, Earth became home. The story of Earth is long, so long that human memory can barely hold it. It began with dust and fire, was shaped by water and ice, and brought to life by time, by chance, and by change. And though the world may seem solid beneath our feet, it is always moving, always becoming something new. Earth is over 4.5 billion years old. It has seen stars born and stars die. It has watched continents drift across its surface like slow waves. It has known silence, storm, extinction, and renewal. And through it all, it has endured, not untouched, not unchanged, but always alive. We, as humans, arrived only recently. If Earth's history were a 24-hour day, we would appear just in the last few seconds before midnight. And yet, even in those seconds, we have left our mark. We've built cities, crossed oceans, sent machines into space. We've mapped the mountains and studied the stars. We've listened to the wind and written down the past. We are part of Earth's story, not above it, not separate from it, but inside it. The air we breathe was shaped by ancient cells. The ground we walk on was forged in the heat of stars. The water we drink once fell as the first rain. We are made of the same atoms as the planet itself. And just like Earth, we are fragile, but strong, temporary, but meaningful. So tonight, as you rest, let yourself feel that connection, not just to the sky or the land, but to the deep and gentle story of the world beneath you. Let your dreams drift through time, across oceans, through forests, into the stars. Let wonder soften your thoughts. Let peace settle over you. And remember, you are part of something vast, something ancient, something beautiful. Sleep well, and may the earth, in all its quiet history, hold you gently until morning.